Have you ever wondered what is behind the success of a leading electric vehicle manufacturer in Vietnam? Today, our team will take you on a journey to discover the answer at Victoria. Our journey begins at Victoria Electric Vehicle Joint Stock Company, where electric vehicles are not only assembled but also associated with the mission of green and sustainable transportation. Join us in exploring the creativity, technology, and relentless efforts at Victoria. Do you know that every year, tens of thousands of electric vehicles bearing the Vietnamese brand are manufactured and delivered to consumers? Who is behind these achievements is Victoria. Established in 2017, Victoria not only leads in manufacturing but also excels in assembling and distributing high-quality motorbikes, electric scooters, and electric bicycles. With an average annual cost of 13.25 million for 60,000 products, the company has solidified its strong position in Vietnam's industries. And to achieve this milestone, Victoria has established a model production line where people and technology work hand in hand to create perfect products. However, alongside its success, the company continues to face challenges in standardizing process and optimizing automation technology. The highlight at Victoria is the continuous dedication of a team of talented and dedicated technicians. Behind each product is a story of effort and desire to go far. The production process at Victoria begins with the import of materials and components from domestic and international suppliers. Every material is meticulously inspected by the KCS department to make sure quality from the start. Plastic and mechanical components are then sorted and stored according to strict standards. Each part is organized to optimize the production process. Next, the components are sent to the assembly lines, where key steps include assembling tires, engines, and frames. The engine, in particular, demands high precision and is assigned a unique serial number for checking. After assembly, each engine undergoes complicated testing, from sealing, sound levels, to ignition performance under real-world conditions. Products that fail to meet the standard are classified and repaired on site. Before leaving the factory, each motorbike undergoes a comprehensive inspection to ensure all details, from braking system to wheel alignment, meet the highest standards. Finally, the complicated vehicles are moved to the central warehouse, carefully packaged and distributed to dealerships across the country. With a modern and seamless production process, Victoria not only produces high-quality products but also solidifies its position in Vietnam's motorbike industry. In the era of Industry 4.0, automation is not only a trend but also a vital factor to improve production efficiency. However, reality shows us many businesses still have difficulty in deploying automated machines. Why is that? Let's explore through the Ishikawa model, a tool for analyzing cause and effect. Firstly, the problem is in the input materials. Uneven quality or non-conformance to production requirements leads to defective products, reducing the efficiencies of the entire process. The human factors also plays an important role. The lack of experience, professionals, and poorly trained staff make it difficult to operate an automated line. Next is the problems in manufacturing process. When the process is not optimized and lacks consistency, the whole system will operate inefficiently. This also makes it difficult for technical staff when they are not properly trained. Measurement system is another issue. When measuring equipment is not accurate enough or modern analytical tools are not available, monitoring and improving productions become nearly impossible. Inappropriate productions and material storage environments, such as the effects of temperatures and humidity, are also important factors leading to poor performance of machinery systems. The manufacturing method serves as the foundations for all operations. However, some businesses still encounter problems such as applying outdated working methods that are no longer suitable for modern technology, and there is no innovations to optimize the process, causing productivities to plummet. These issues not only slow down progress, but also increase defect risk and production costs. To overcome the challenging, business need to invest around $5 million in quality raw materials, improve human resource capacity, and modernize process and system. Automation is not just a trend, it is a key to leadership. Currently, Victoria operates with an SOP that, while functional, face challenges such as inconsistent raw material quality, manual data entry, and outdated production lines. To handle this issue, we propose key improvements to enhance efficiency and productivity. Our proposed SOP introduces targeted changes, aimed at streamlining operation and solving existing inefficiencies. Let's explore the key recommendations. First, negotiating contracts with suppliers to secure higher quality raw materials at more competitive price. This will stabilize the supply chain and reduce variabilities in input quality. Second, implementing advanced management software for data entry and tracking. This will have eliminated manual errors, enhance accuracy, and provide real-time insights into inventory and production metrics. Third, upgrading production lines with semi-automations to increase operational efficiency, reduce manual labor dependency, and make for consistent product quality. If implemented, this trend could boost production capacity by 50% from 40,000 to 60,000 units annually, while achieving cost savings of $6.545 million per year. By adopting these proposed changes, Victoria could position itself as a more efficient and competitive player in the industry, ready to meet future demand. These recommendations serve as a roadmap for Victoria to drive innovation, reduce inefficiencies, and achieve sustainable growth in the years to come. Here is our Gantt chart, which illustrates the timeline for three key objectives: negotiating with suppliers, utilizing management software, and improving production life. For negotiating with suppliers, the tasks include research and preparation in the first week of January, followed by conducting negotiations and finalizing contracts in 3 weeks left in January. Using management software begins with selecting the software from January to mid-February, entering initial data from mid-February to mid-March, and conducting data analysis from mid-March to April. Lastly, improving production lines involves analyzing and optimizing process from mid-April to mid-June, implementing new technologies from March to June, and completing monitoring and evaluation from April to June. The chart effectively outlines the sequential flow of tasks, ensuring efficient project management and clear prioritization over 6 months. To evaluate the effectiveness of our proposed solutions, we have identified key performance indicators, or KPIs, that highlight improvement across different aspects of Victoria's operations. These KPIs are designed to measure success in production, efficiencies, cost reduction, and safety. Let's start with production output. With the improved process, we aim for a 40% increase in annual production, raising capacities from 40,000 to 56,000 units per year. This reflects the overall efficiencies gained across operations. To achieve this, we approach reduction production times by 30%, ensuring faster throughput without compromising quality. And at the same time, by integrating automation, we expect a 40% decrease in the number of employees required, allowing Victoria to optimize labor costs while enhancing operational efficiency. This efficiency is further boosted by a 50% increase in capacity utilization, ensuring that resources and infrastructure are used to their full potential. Improved process also mean better quality. We target a 3% increase in first batch yield, reducing rework and ensuring that products meet standard on the first attempt. This trend impact costs with a projected 32% decrease in cost per unit, making Victoria's products more competitive in the market. This, in turn, drives revenue growth. We anticipate a 50% increase in revenue, a clear indicator of the market's positive response to these improvements. Safety is another critical focus. By implementing enhanced training and safety protocols, we aim to achieve a 40% reduction in workplace incidents annually. Lastly, we prioritize sustainability by targeting a 2% decrease in energy consumption per unit, contributing to both cost savings and environmental goals. This journey to Victoria's has been an invaluable experience for us as students, giving us a closer look at the real-world applications of production management and the challenges faced by a leading manufacturer in Vietnam. Through this visit, we have gained practical insights into how theories from the class come to life, from the intricacies of supply chain management to the importance of innovation in production. We extend our thanks to Victoria for welcoming us into the facilities and sharing valuable knowledge about the operations. Your hospitality and openness made this visit truly memorable. A special thanks to our Professor Sorens, who has guided and encouraged us throughout this project. Your support has been instrumental in helping us understand and apply this concept effectively.